Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Dear student, in this second video lecture of week 6 for the course Applied Mathematics 2, today we are going to learn about the last case of finding an integral factor for the solution of non-exact differential equations. Dear students, this video lecture is the continuation of my previous last 3 video lectures. In the last 3 video lectures, we have discussed already 3 cases: case number 1, case number 2, and case number 3 for finding an integral factor for the solution of non-exact differential equations. Dear students, why we need an integral factor for the solution of non-exact differential equations? Because first of all, we find an integral factor, then we multiplying that integral factor to the non-exact differential equations. By multiplying the integral factor with the non-exact differential equations, the non-exact differential equation transform to an exact differential equations, and then we can solve easily the non-exact differential equations when non-exact differential equation transform to an exact differential equation form. So dear students, when we need the solution of non-exact differential equations, then we need an integral factor. For finding an integral factor, there are 4 cases, there are 4 rules. So in this video lecture, we are going to learn case number 4 for finding an integral factor. So this is the last rule for finding an integral factor. In this video lecture, first of all, I would like to repeat the non-exact differential equations, and then I would like to tell you about the case number 4, about the rule number 4 for finding an integral factor for the solution of non-exact differential equations. Actually, we transform the non-exact differential equation into exact differential equation forms. So for this purpose, we need an integral factor. I would like to tell you again about the non-exact differential equation. Suppose we have a first order differential equation. M is a function of x and y dx plus n, where n is the function of x and y dy is equal to 0. If partial m by partial y does not equal to partial n by partial x, then the given differential equation is said to be a non-exact differential equation. And if the given differential equation is not exact, then make that equation exact by finding an integral factor. In general, suppose we have the first order differential equation m dx plus n dy is equal to 0. And if this equation is not exact, in such situation, we find a function lambda such that by multiplying lambda to the equation, it becomes an exact differential equation. So to multiply this lambda to the given differential equation, we obtain lambda m dx plus lambda n dy is equal to 0. And now the equation become an exact differential equation. And here the function lambda will be the function of x and y, which is called an integral factor. So the method for finding an integral factor for the non-exact differential equation, this is a non-exact differential equation, m dx plus n dy is equal to 0. So for the integral factors, there are 4 cases in which we are going to discuss the 4th case today. Suppose we have a differential equation in the form of f1
xy into y dx plus f2 of xy x into x dy is equal to 0. And with the condition mx minus ny does not equal to 0, then the integral factor will be 1 over mx minus ny. Suppose, let's move on an example. We have a differential equation x square y square plus 2 into y dx plus 2 minus x square y square into x dy is equal to 0. To check whether this differential equation is exact or non-exact, so this is the function of m x square y cube plus 2y. To multiply this y to this expression, we get m function is x square y cube plus 2y, and the n function is 2 minus x square y square into x. So taking the partial derivative of m function with respect to y, using the power rule, we get 3x square y square, and the partial derivative of this term with respect to y is 2. Now taking the partial derivative of n function with respect to x, multiply this x to 2, we get 2x, and the derivative of 2x with respect to x is 2, and multiplying this term to this term, we get x cube y square, and the derivative of x cube y square with respect to x will be, using the power rule, minus 3x square y square. Since these two partial derivative are not equal, partial m by partial y does not equal to partial n by partial x, so this differential equation is a non-exact differential equation. And since this differential equation is the form of f1 of xy into y and f2 of xy into x dy is equal to 0. So first of all, find mx minus ny. If mx minus ny does not equal to 0, then the integral factor will be 1 over mx minus ny. So mx minus ny. So this is the m function, x square y square plus 2 into y multiplied x minus, this is the n function, 2 minus x square y square into y into x, this is the n function, into x into y. The n function is 2 minus x square y square x and multiplied y. So multiplying these expression, we get x cube y cube plus 2xy minus 2xy minus minus plus x cube y cube. So these two terms cancel, and x cube plus y cube are like term, so adding these two terms we get 2x cube y cube. So mx minus ny is equal to 2x cube y cube, which is not equal to 0. So the integral factor is now 1 over mx minus ny, 1 over 2x cube y cube. So this is the integral factor. Now multiplying this integral factor to the given differential equation, this is the given differential equation, x square y square plus 2 into y dx plus 2 minus x square y square x into dy is equal to 0. And after multiplying this factor to the m function and to the n function, we get 1 over 2x plus 1 over x cube y square into dx plus 1 over x square y cube minus 1 over 2y into dy is equal to 0. Now this is the new differential equation. So, and this new differential equation, now this is the m function, 1 over 2x plus 1 over x cube y square, and this is the new n function, which is equal to 1 over x square y cube minus 1 over 2y. So the partial derivative of m with respect to y, again check this new differential equation is exact or non-exact, whether this new differential equation is exact or non-exact. To find partial m by partial y and then find partial n by partial x. if partial m by partial y equal to partial n by partial x, then this new differential equation will be exact. So first of all, to find partial m by partial y, with respect to y, the derivative of this term is 0, and the derivative of this term is minus 2 divided by x cube y cube. So now the derivative of the n function with respect to x, the derivative of this term is 0, and the derivative of this term with respect to x is minus 2 divided by x cube y cube. Since these two partial derivatives are equal, partial m by partial y equal to minus 2 divided by x cube y cube, and partial n by partial x also equal to minus 2 divided by x cube y cube. So this new differential equation is an exact differential equation. So we can find its solution by using the formula integration of m function with respect to x plus integration of n terms, but those terms of n which not containing x with respect to y is equal to c. So this is the m function. In the new differential equation, the m function is 1 over 2x plus 1 over x cube y square. So this is the m function, and there is only one term which not containing x in the n function, which is minus 1 over 2y. In the n function, there is only one term which not containing x, which is minus 1 over 2y. So the integration of this term with respect to x, the integration of 1 over x is log x, minus the integration of this term is equal to minus 1 over 2x square y square minus 1 over 2, and the integration of 1 over y is log y is equal to c. So this is the solution of the new this differential equation. Now another example, suppose we have another example, y into xy plus 2x square y square into dx plus x into xy minus x square y square into dy is equal to 0. And this differential equation, the m function is equal to xy square plus 2x square y cube, multiplied this y term to this given differential equation, and the n function is x square y minus x cube y square. First of all, check whether this differential equation is exact or non-exact. So find the partial derivative of m function with respect to y using power rule 2xy, and the derivative of this term with respect to y using the power rule 2 3 the 6x square y square, and the derivative of n function with respect to x using the power rule using the power of x 2xy, the derivative of this term is equal to 2xy minus the derivative of this term with respect to x using the power rule and using the power of x minus 3x square y square. Since the partial derivative of m with respect to y and the partial derivative of n with respect to x are not equal, so this given differential equation is a non-exact differential equation. And dear students, note that since this differential equation is in the form of y into f of xy dx plus x and g is another function of xy dy is equal to 0. And another wording, we can say that the given function is in the form of f1 xy into y dx plus f2 of xy into x dy is equal to 0. And the subtraction of mx minus ny is equal to, this is the m function multiplied x minus this is the n function multiplied y, and multiplying these terms, and after simplifications we get 3x cube y cube, and this is not equal to 0. So the integral factor is equal to 1 over mx minus ny. So 1 over 3x cube y cube is the integral factor. Now multiplying this integral factor to this given differential equation, we obtain 1 over 3x cube y cube into y into xy plus 2x square y square into dx plus, this is again the integral factor, 1 over 3x cube y cube into x into xy minus x square y square into dy is equal to 0. Now after simplifications, now this is the new differential equation, and this new differential equation after simplification, the new function m is equal to 1 over x square y plus 2 divided by x, and the new n function is equal to 1 over xy square minus 1 over y. Now check this new differential equation is whether this new differential equation is exact or non-exact. So find again the partial derivative of m with respect to y. The partial derivative of m with respect to y, the derivative of this term with respect to y is 0, and the derivative of this term with respect to y is equal to minus 1 over x square y, and the partial derivative of n function with respect to x, the derivative of this term is 0. So the partial derivative of this term with respect to x is equal to minus 1 over x square y. Since these two partial derivatives are now equal, so this new differential equation is now an exact differential equation. So we can find a solution easily by taking the integration of m function with respect to x and the integration of n terms, but those terms of n which not containing x with respect to y is equal to c. So this is the m function, the integration of m function with respect to x, and the integration of those terms of n which not containing x. There is only one term, an n function which not containing x, and the term is minus 1 over y. So the integration of minus 1 over y with respect to y is equal to c. So the integration of 1 over x square y with respect to x, we get minus 1 over x y, and the integration of 1 over x, 2 is constant term, and the integration of 1 over x is log x, and the integration of 1 over y is log y is equal to c. So this is the required solution. And dear students, this is the end of this segment. Thank you. Allah Hafiz.